Hello everyone, welcome back to my YouTube channel Chemical Adda. In today's video, we are going to learn about a very important concept in heat transfer operations. Fin tube heat exchangers. By the end of this video, you'll clearly understand. What is a fin tube heat exchanger? Why fins are needed in heat exchangers? And typical examples where fins are applied. Then we will see different types of fins and their uses. Next, fin materials and efficiency. And lastly, we will see applications, advantages and disadvantages of fin tube exchangers. Alright, let's get started. So, first let's understand what is fin tube heat exchanger. So, a fin tube heat exchanger is a type of heat exchanger where thin metal fins are attached to the outside of tubes. In simple terms, it is a device where fins are fixed on the outer surface of tubes so that they act like extra surface area. And because of this, more heat can transfer between the fluid flowing inside the tube and the fluid flowing outside. In short, by simply adding fins, the effective surface area for heat transfer increases, which makes the exchanger more efficient than plain tubes. Now, let's understand in detail why fins are needed in heat exchangers. So, as we know, when two fluids are brought into contact in a heat exchanger, the rate of heat transfer depends on the overall heat transfer coefficient. But this overall coefficient is not an average of the two sides. It is strongly controlled by the fluid that has the lower individual heat transfer coefficient. For example, if one fluid has a very high coefficient, like steam, and the other has a very low coefficient, like air or a viscous liquid, then the overall coefficient will not remain high. Instead, it will drop down and become almost equal to that of the porous fluid. But what will happen because of that? So, the first practical consequence is that the ability of the heat exchanger to transfer heat per unit area becomes much lower. Then, to achieve the same heat duty, the exchanger would require a very large heat transfer surface. In other words, no matter how good one fluid is at transferring heat, the weak side limits the performance of the entire system. And therefore, to prevent the design from becoming expensive, fins or other extended surfaces are used in heat exchangers. Because these fins increase the outside surface area of the tubes, allowing the porous heat transfer fluid to come in contact with a much larger area. And typically the fluid with the low heat transfer coefficient flows outside the tubes, over the fins. And the fluid with the high heat transfer coefficient flows inside the tubes. So by doing this, the overall exchanger efficiency improves significantly while keeping the design compact and economical. Now, let's understand typical situations where fins are especially useful. So, to understand this better, let's look at a couple of common situations where fins are especially useful. First situation is heating of gases, like air, by condensing steam. In this case, steam has a very high heat transfer coefficient, often 100 to 200 times greater than air. But air is the limiting side, the overall coefficient is nearly equal to that of air. And as a result, a very large tube length would be needed, without fins. Then the second situation is heating of viscous liquids, by condensing steam or another hot liquid. So, in this case, viscous liquids or fluids flowing at low rates generally exhibit laminar flow, leading to poor heat transfer. That's why fins are used, which help to increase surface area, which compensate for low heat transfer. Now, that we know why fins are used, so, let's look at their different designs and applications. Hence, let's see what are the different types of fin and their application. So basically, fins are designed in different shapes depending on the application. But there are four main types of fins. First one is longitudinal fins. Second one is transverse fins. Third one is plate fins. And fourth one is pin fins. Let's see this one by one. First, let's see about longitudinal fins. So, these fins are used when the direction of fluid flow is parallel to the axis of the tube. And hence, in this case, long metal strips or channels are attached to the outside of the pipe. Then, they can be fixed by grooving and peening the tube or by continuous welding along the base. Then, longitudinal fins are commonly used in double pipe heat exchangers, especially where gases or viscous liquids are flowing parallel to the tube axis. They are very effective when the fluid has a low heat transfer coefficient. But there is one drawback: they are relatively expensive and cannot be easily cleaned. So, they are generally used only for clean fluids, or in cases where any dirt that forms can be boiled out. Now, let's look at transverse fins. So, the transverse fins are used when the fluid flow is across the tube, that is, at a right angle to the axis. And that's why, here, metal pieces are attached around the pipe, usually by grooving and pinning, or sometimes by welding. Then the example of transverse fins is disc-type fins, which are transverse fins usually welded to the tube. Next is helical fins, which are made by attaching a ribbon continuously around the tube, often by welding. Next type is discontinuous fins, such as star fins. Then next point about transverse fin is, these fins are widely used for heating or cooling large quantities of gases in cross-flow, such as economizers, air-cooled steam condensers for turbines, and engine cooling systems. Then it is also used in shell and tube exchangers for gas cooling. Then let's see third type of fin is plate fins. Here, thin plates are attached perpendicularly to the tubes. That's why they provide a large surface area and also create turbulence, which increases the heat transfer rate. Then, plate fins are widely used in compact heat exchangers, like those in refrigeration, cryogenics, and aerospace industries. Then let's see last type of fin is pin fins. In this type, short rods or pins are attached to a surface, such that they can be cylindrical or square, tapered, and concave in shape. Then next point about pin fin is, they are very effective for increasing surface area in a compact design. And they are often used in electronics cooling, some automotive applications, and certain compact heat exchangers. So in short, in longitudinal fins, flow is parallel to tube axis, used in double pipe exchangers, for gases, viscous liquids, low heat transfer coefficient fluids. Then in transverse fins, flow is across the tube, used in cross-flow exchangers, like economizers and condensers. Then in plate fins, thin plates mounted on tubes, used in compact exchangers like refrigeration and aerospace. And in pin fins, short rods is used to increase area, used in electronics cooling and compact heat exchangers. Now, let's understand, how does the choice of material affect fin efficiency and design? So, the material of fins plays a very important role in their performance, and the effectiveness of a fin depends not only on its shape and size, but also on the thermal properties of the material used. So, fins are usually made from highly conductive metals such as copper, aluminum, or steel, because the choice of material directly affects their efficiency. Copper has the highest thermal conductivity and provides excellent heat transfer, but it is both heavy and costly, which limits its use in larger exchanges. On the other hand, aluminum offers good conductivity and is lightweight as well as naturally corrosion resistant, which is why it is widely used in HVAC systems and automobile radiators. Steel, though it has a much lower conductivity, is strong, durable, and economical, making it suitable for heavy-duty industrial applications. Then as we know, the efficiency of a fin is defined as how effectively it transfers heat, compared to its theoretical maximum, and this efficiency is influenced by several factors, such as the thermal conductivity of the material, fin thickness, fin length, and surface condition. Therefore, the selection of fin material is always a balance between performance, cost, mechanical strength, corrosion resistance, and weight considerations. In practice, the application largely decides the choice. Copper is preferred in compact, high-performance exchangers. Aluminum is commonly used in air conditioning, refrigeration, and automotive cooling systems, while steel finds its place in boilers, furnaces, and other industrial units. So in short, the choice of fin material directly impacts efficiency, cost, and durability. Now let's understand, what are the applications of fin tube heat exchangers? First application is, they are widely used for heating gases, like air, using condensing steam. Since gases have a very low heat transfer coefficient, the fins help increase the area and improve heat transfer. Second is, they are used for cooling of hot gases, for example, cooling of flue gases or exhaust gases in process plants. Third is, in the case of viscous liquids such as oils, tar, or polymer solutions, fins play an important role, because these fluids also have poor heat transfer properties. Fourth is, fin tubes are used in condensers for distillation and other chemical operations, where steam condenses outside the tubes to heat another process stream. Fifth is, they are essential in waste heat recovery units, like economizers in boilers, where heat from hot gases is recovered to preheat water or air. Sixth is, they find applications in evaporation and drying units, where heat must be supplied efficiently for vaporization or drying processes. And finally, they are used in refrigeration and cryogenic processes, for example, in air coolers for ammonia or LNG plants. Now let's understand, what are the advantages and limitations of fin tube heat exchanger? So, fin tube heat exchangers offer several important benefits. So, the first advantage is, as we know, since fins provide an increased heat transfer area, they improve performance without making the exchanger bulky. And as a result, the equipment becomes compact and lightweight compared to plain tube exchangers. Then next advantage is, they are also a cost-effective solution when one of the fluids has a poor heat transfer coefficient, because fins help compensate for the limitation. Then another advantage is their flexibility, so the fin tube heat exchanger can handle gases, vapors, and even viscous liquids, while operating reliably under a wide range of temperatures and pressures. Now let's see, what are the limitations of fin tube heat exchangers? So, despite their benefits, there are also some drawbacks. So the first limitation is, fins are prone to fouling and dust deposition, especially when air is the process fluid, which reduces efficiency over time. Next is, cleaning and maintenance are more difficult compared to plain tube exchangers. Then next limitation is, the manufacturing and attachment of fins add to the initial cost, and their efficiency depends heavily on the choice of material and operating condition, and if the design is not correct, the expected benefits are lost. In addition to this, one more limitation is, mechanical damage, such as bending or corrosion of fins, can significantly reduce performance in a short period. Alright, now let's wrap up today's topic. So, we learned that a fin tube heat exchanger is simply a tube with fins attached to increase the heat transfer area. They're especially useful when one fluid, like air or viscous liquids, has poor heat transfer. Then we also saw the different fin types, longitudinal, transverse, and spine, and how materials like copper, aluminum, and steel affect their performance. Then we see that these exchanges find wide use in power plants, HVAC, chemical industries, food processing, and automobiles. Then we learned, very important point about fin tube heat exchanger is, fins make heat exchangers more efficient, compact, and cost effective, though they do come with some challenges like fouling, maintenance, and higher initial cost. That's all for today's video. If you found this helpful, don't forget to like, share, and subscribe to Chemical Idda for more easy explanations of chemical engineering concepts. See you in the next video.